our guest of honor, Mr. Heng Swee Keat, Deputy Prime Minister and Coordinating Minister for Economic Policies, Mr. Telson Chung, and Professor Lim Kok Hwa, Conference Chairs for WES 2021 Organizing Committee. Distinguished guests, ladies and gentlemen, good morning. We welcome all to the World Engineers Summit 2021 opening ceremony. I would first like to express our appreciations to DPM Heng Swee Keat for gracing this morning event as our guest of honor. Thank you, DPM. Due to safety management measures, this year, WES has to be carried out in a hybrid format. But the fact that we are making it happen shows the determinations of engineers to overcome hurdles for the benefit of our society. Whether you are joining us in person or online, thank you for your participation. Every 2 years, since 2013, engineers from all around the world would convene in Singapore to discuss solutions aimed at tackling critical issues of our time. The past 4 conferences covered issues such as climate change and carbon-intensive urban development, driving actions towards strengthening global climate resilience, promoting sustainable development, and improving our quality of life. This year, we have chosen engineering towards a post-pandemic sustainable world as the conference theme. As the COVID-19 pandemic is one of the most pressing global issues at this juncture, creating a better future for mankind beyond pandemic starts with embracing a paradigm shift that comes with a new normal. Our world will not return to its pre-COVID-19 days. And that's call for a new ways of doing things and charting a new pathway forward. Engineers must adapt to this new reality by thinking deeper, looking further, and reacting faster to emerging challenges. We must also constantly think out of the box and forge better collaborations with other engineers. Since the pandemic started, many engineers have wasted no time in developing solutions to keep us safe and enable us to live life as normal as possible. In Singapore, for example, our engineers have contributed to the development of innovative solutions such as trace together apps and disinfection robots. We hope that WES 2021 will serve as a platform for more such engineering innovations to be converted into solutions. Solutions that support our fighting against the COVID-19 pandemics and give us a more sustainable future. Our organizing committees has thoughtfully curated 6 topics that are closely tied to post-pandemic developments toward a sustainable future. These topics are sustainable living through technology, 2, future engineering and industry 4.0, 3, AI and digitizations, 4, urban sustainable solutions, 5, engineering educations, and 6, impact of new technologies of productizations, safety, and human factor practice. These are the 6 threads will facilitate discussions such as the importance for engineers to accelerate their adoption of digitizations and the need for institutes of higher learnings to reimagine engineering educations to better prepare engineering students for the future. I understand that we have about 500 delegates joining us for this year's conference. And this conference will be presenting 67 papers across 6 tracks, as just now has shared by Delson. Thank you all for all the strong supports. I would like to once again thank DPM for his presence this morning. My appreciation also goes to all our sponsors, the WES organizing committees, and all our partners for making WES happen during these challenging periods. And it's always said that as engineers, we dare to dream and we dare to do. At IES, we always believe in power of unity. Our engineers, one engineer alone may be able to develop good solutions. A team of engineers could develop great solutions. But when engineers across disciplines and borders work together, they could redefine lives, and not just current, but future generations. I wish all of you a rewarding conference. Thank you.
Thank you, Dr. Kwok. Dare to dream, dare to build. And the second point on unity. Engineers not alone, but as a team, and further than that, as a team beyond borders across the world. There's an interesting point that I took from Dr. Kwok's speech. Government agencies, industry partners, institutes of higher learning, and the community, the people they serve. All 4 of them together, engineers across them, working together to create this new sustainable world post-pandemic. And with that, it is now my great pleasure to invite our guest of honor, Deputy Prime Minister and Coordinating Minister for Economic Policies, Mr. Heng Swee Keat, on stage to address us. DPM Heng, please.
Dr. Richard Kwok, President of the Institution of Engineers Singapore, Mr. Delson Chong and Professor Lim Kok Hua, Co-Chairman of the World Engineers Summit, ladies and gentlemen, including many of you who are joining us virtually from Singapore and from around the world. A very good morning to all of you. It's my pleasure to join you all today at the opening ceremony of the World Engineers Summit. This is the 5th edition of this biennial summit. Over the years, the summit has been valuable for engineering professionals, researchers, and business leaders to exchange views and forge collaborations. Despite COVID-19, engineers solve problems, and I'm glad that the Institution of Engineers and its partners have put together a very rich program with many distinguished speakers. Engineering is a key locomotive for the progress of human societies. It is remarkable that some ancient engineering marvels are still standing today after thousands of years, such as the Giza pyramids, the Roman aqueducts, and the Tujiangyuan in China. Over the centuries, the world has been transformed by successive breakthroughs. During the current pandemic, as President Richard mentioned earlier, the value of engineering has also come to the fore. From contact tracing apps to machines that can automate the extraction of vaccines from their vials, to the 3D printing of critical components. We are now at the cusp of yet another engineering renaissance. The first three industrial revolutions led to exponential growth. The fourth industrial revolution will do the same and more. It will be far more pervasive, fusing the physical, digital, and biological worlds. A host of transformative technologies, AI, robotics, IoT, quantum computing, will fundamentally change the way we work, live, and play. But technology is ultimately just a tool. The critical question is, how can we harness its potential to engineer solutions to improve lives? In the years ahead, there will be many complex challenges facing the world. Thinking long-term, one clear challenge that we must tackle is sustainability. Climate change and its impact on biodiversity are critical issues. The ongoing COP26 has put an added spotlight on the urgency of tackling global emissions. There are many other global challenges as captured in the UN Sustainable Development Goals, and we are far from achieving the 2030 targets. The theme of this summit, engineering towards a post-pandemic sustainable world, is particularly apt. I was almost an engineer. I intended to study engineering because, as Delson said earlier, engineers solve problems, and I enjoy solving problems. But when I received a government scholarship, they preferred that I study economics. I was told that they needed people who know how to count money. So now I try and solve problems by counting money and distributing money, which was what I did a lot of last year. But at the core of it, economics and engineering share a common purpose: to improve the human condition, to improve lives, while dealing with constraints. And I believe the coming years will be a golden era for engineers to make major contributions to the world as we go through a period of rapid innovation. Over the years, I've worn many hats, driving innovation as coordinating minister for economic policies and as chairman of our National Research Foundation, allocating resources in the finance ministry, and nurturing our people as former education minister. So allow me to share with you some of my thoughts on what could enable this era of engineering to flourish from the perspective of each of my roles and previous roles. My first point is from the innovation perspective, how a more integrated and interdisciplinary approach is required to tackle the challenges of tomorrow. The term engineering was derived from military engineering in the 14th century, or the building of military machines. Over time, various branches of engineering developed, each time with its own deep specialization: mechanical, electrical, civil, computer, environmental, and so on. These deep specializations have also resulted in deep innovation. But the boundaries around these various disciplines are blurring. As challenges are becoming much more complex, to tackle them effectively, we need a much more holistic and interdisciplinary approach. Take the modern car. In the past, the car was primarily a mechanical engineering challenge, but the modern car is a computer on wheels with up to 100 million lines of code, more than in some jet fighters. With autonomous vehicles, we can expect even more computing power and technologies packed into a vehicle. Building cars of the future will be an integrated and interdisciplinary endeavor. This is how we are also approaching our national challenges under the Research, Innovation and Enterprise 2025 plans. As part of these plans, we've committed $25 billion over the next 5 years. Beyond funding basic research, we have also organized our efforts around key domains, such as advanced manufacturing, health and human potential, and urban solutions. And sustainability is also a key area of focus as we work towards making new technologies, such as carbon capture and low-carbon hydrogen, more feasible for scaling and adoption. In our universities, we are encouraging our academics to take an interdisciplinary approach to teaching and research. Increasingly, it is not just about the interweaving of various STEM disciplines, but also integrating the arts and humanities in our work. And globally, we are seeing a growing interest in moving from STEM to STEAM. We're also encouraging our researchers to collaborate with their peers from other institutions within Singapore and globally. So I'm very happy to see that there are many of you online joining us from various parts of the world. To better translate research into outcomes, we're also strengthening the linkages between industry, academia, and government. By working together, we make the most of our efforts and resources. I encourage all of you, including our friends from abroad, to be part of this collective innovation journey as we engineer new solutions in a post-pandemic world. My second point is about resources. The hard truth is that needs and wants are unlimited, but resources are finite. In a market-based economy, resources and attention gravitate towards where the greatest returns are. And this is how we achieve the greatest efficiency. In engineering, this often means developing cutting-edge products or building new infrastructure. Existing products and infrastructure that keep us going tend to draw less attention until it is too late. Maintenance is not glamorous, but as we build new skyscrapers, we must not forget the plumbing and the utilities network that keeps it functional. Keeping existing infrastructure going is often more complex than we give our engineers credit for. Even as we build more and greener data servers to meet the growing appetite for data, we must also remember that some of the most critical systems around the world are still on mainframe. This means that some engineers will need to know COBOL, as this is a computing language that mainframes are coded in. And beyond understanding new possibilities of cloud computing, we must also know the limitations of mainframes. Unlike data servers, most of the physical infrastructures that we live in today have been built over many decades. In many countries, the lack of maintenance over the years has led to major problems. In the US, President Joe Biden described some of the existing infrastructure in the US as crumbling. Climate change is also accelerating the erosion of existing infrastructure. Melting permafrost due to global warming is damaging roads and buildings. Singapore is a relatively young nation. Most of our infrastructure is only a few decades old. But some of the infrastructure is starting to age, and we too will have to devote more resources and attention to them. I think your president, Dr. Richard Kwok, would know this very well because he has been doing a lot of work in ensuring that our trains run properly. And he has succeeded very well. So we must renew our efforts to think about infrastructure on a life cycle basis. Design for maintainability is an approach that we must give much more weight to for new projects. Maintenance should not just be an afterthought, but a critical aspect of owning an asset. We must design our infrastructure and capital assets to minimize our carbon footprint and future-proof designs. Designing for the long term will lead to higher upfront costs, but this could well be more economical over the entire life cycle. What I have set out relates to new projects, but there are many existing infrastructure that will be with us for a long time. So let me take this opportunity to commend our engineers who are maintaining our existing infrastructure and keeping it running. Thank you for keeping the light bulbs going and the pipes flowing. I also commend your efforts to place greater emphasis on designing for safety, as we saw in your Vision Zero pledge earlier. I think the Institution of Engineers is the first institution to make an explicit recognition of the importance of safety. The work that you do in all this area is important, although it's sometimes underappreciated. So it's important for us to recognize your contributions, and I hope too that our engineers will continue to raise your skills level so that you can make the most of the assets that you're operating with. This brings me to my third point, our people. We must continue to inspire the next generation of engineers to pursue their passion. This starts from a young age by providing our next generation with a strong foundation in STEM education and to encourage them to pursue their interest in a wide range of STEM disciplines. To inspire the next generation of engineers, it is important to go beyond the classroom. I'm glad that schools are offering applied learning programs in STEM, and we can pick students' interests through maker fairs and other activities. There are also many competitions that encourage our students to develop peaks of excellence, including the Science and Engineering Fair, National Robotics Competition, and the Engineering Innovation Challenge. For many, concepts like robotics, AI, or materials engineering are not as relatable. By exposing them to these fields in their schooling years, we can evoke a sense of curiosity and spark an interest in these areas from an early age. We must also make a concerted effort to empower women to pursue STEM careers. Around the world, there remains a persistent gender gap in STEM participation. In Singapore, the situation has improved over time, but the disparity remains. In addition, fewer women who graduated in STEM pursue a career in a related field compared to men. We're doing more to encourage women participation. President Halimah Yacob launched the POWERS program earlier this year to create a supportive ecosystem to build the next generation of women leaders in STEM. There are also many other ground-up efforts. In East Coast, we launched a bursary this year to support women who are pursuing their studies in STEM. More broadly, a good network of role models can inspire and support the next generation of engineers. Many of our institutions of higher learning are already doing this, connecting their students to industry mentors and alumni. IES is also doing good work in this area. Your incubator and accelerator grooms startups in engineering and deep tech, with mentoring as an important pillar of the process. I encourage more of you to step forward and play a part in shaping and inspiring the next generation of engineers. Let me conclude. It is a very exciting time to be an engineer. I just shared my thoughts on what could enable this era of engineering to flourish through a more integrated and interdisciplinary approach to innovation, by focusing as much on the existing as we do the new, and by inspiring the next generation of engineers, including women. This World Engineers Summit, hosted by the Institution of Engineers, provides an excellent opportunity to explore how we can do each of these three areas better, and in fact, to discuss many other new ideas. So with so many engineers from Singapore and from around the world at this summit, I trust that your curiosity and ingenuity will spark fresh ideas for new pathways and breakthroughs. So let us take this opportunity over the next 3 days to exchange perspectives, forge collaborations, and deepen partnerships. I wish all of you an enjoyable and fulfilling conference. Thank you.
Thank you, DPM Heng. DPM Heng, we'd like to invite you to please remain on stage. We have a very special launch event prepared. Now, I'm sure all the engineers tuning in from online and those gathered here today will join me in recognizing that while DPM Heng was a student of economics, he is indeed an engineer at heart and takes that professional rigor that engineers do every day in every aspect of nation building. I'd like to invite on stage to help launch the World Engineers Summit 2021, Dr. Richard Kwok, IES President, Mr. Dalson Chung, IES Deputy President and Co-Chair of the World Engineers Summit 2021 Organizing Committee, Prof. Yo Lien Weng, IES Immediate Past President, and Engineer Professor Lim Kok Hwa, Co-Chair of the World Engineers Summit 2021 Organizing Committee. Now, As we've heard from the different speeches by our three guests on stage earlier today, one engineer can't make that big of a difference, but a team can. So we've assembled that team on stage to launch the World Engineers Summit. Now, in front of you is a tablet. It's waiting for an authentication. Now, on your mobile devices, we have the digital identification card. Now, we'd like to request all our guests on stage to use your digital IDs through your SingPass on your mobile devices so that it synchronizes on that tablet. Once it's established that you are there, digitally, we will launch the event. So I'd like you to hold your phones up to the screen for 3 seconds. 1, 2, 3. Here we go. All right, ladies and gentlemen, it's authenticating. Ladies and gentlemen, here we go. In 5, 4, 3, 2, 1. The World Engineers Summit 2021 is officially opened. Gentlemen, I'd like to request that you remain on stage for a group photograph to capture this momentous occasion. Now, I'd like to say big smiles for the camera, but with our masks on, smile with our eyes. At this time, I'd like to invite IES President to present a token of appreciation to DPM Heng for gracing this launch event. Thank you, gentlemen. Now we have a lot of exciting exhibits set up right outside this conference hall. And it is my great pleasure to invite our guests on stage to lead the way to the exhibitions. Now, ladies and gentlemen, we have an exciting day of events happening today and over the next 3 days. In your program booklets, in your goodie bags, you will see the programs and you can take note of all the activities you're interested in and you'd like to be a part of. Now, remember, we have a global audience tuned in as well to all the events. If you'd like to join virtually as well, you may choose to do so too. Now, in line with our safe management measures, we do have hand sanitizers located at every corner of your seating zones. In the event you do need to exit your respective seating zones, do take note to sanitize your hands before proceeding outside. Now, once our guests have made their way to the exhibition hall, we'll be taking a very short break so that you can refresh yourselves as well. All right, ladies and gentlemen, we'll be taking a very short break. We'll begin again in a little bit with our plenary session on engineering in a sustainable world with Professor Cho Seok Kyang as our moderator. Till then, enjoy yourselves. Ladies and gentlemen, we hope you've enjoyed your refreshments. A gentle reminder to all guests, if you're not consuming any food or drinks, we kindly request you keep your masks on at all times. As you move out of your respective zones to go to the restrooms, please do remember to sanitize your hands. Thank you. I'd like to remind all guests that we will have a plenary session on engineering in a sustainable world starting in just a little bit. Our team here at Resorts World Sentosa will be clearing all food and beverages from the table before we finish or before we start that plenary session. Thank you. Ladies and gentlemen, please take your seats. We'll be commencing our plenary session on engineering in a sustainable world in just a little bit. I'd also like to remind all guests to keep all beeping devices off or to the silent mode. Thank you. A very good morning, ladies and gentlemen, and welcome back to the World Engineer Summit 2021. We'll now be having our plenary session on engineering in a sustainable world. Now, it is my great pleasure to invite our very first plenary speaker, Ms. Susanna Kaas. Ms. Susanna Kaas is an energy fellow at Stanford University, a data center advisor to the UN SDG program, and she engages the private sector leadership, academic researchers, and public institutions to jointly promote sustainable energy within the international data center industry on Clean Energy Fund and Carbon Neutral Pledge. Please welcome her to give us her presentation on Race to Net Zero Thought Leadership.
Good morning, everyone. And good evening or good afternoon, depends on where you are calling in from the world today. My name is Susanna Kaas. Thank you for having me to join your wonderful event at the World Engineer Summit. Very impressive for the keynote speaker that you have the guest of honor. This year, the theme is engineering towards a post-pandemic sustainable world. It is a timely opportunity for all of us to come together as an international engineering communities, regardless where you're physically located or what your discipline might be. My plea today is to please invert the status quo of living in the linear economy. It is time to embrace circularity. You are also fortunate to have in residence one of the world's brightest minds, Professor Saram Ramakrishna. He is brilliant in this field of circularity, and he taught me many wonderful ideas and inventions that can be applied for the ICT infrastructure during the pandemic. And we still actually have not met, but we definitely still collaborate through technology. So I'm also requesting all of you to connect with me, along with the world scientists, academic scholars, who are passionate to believe in circularity for ICT infrastructure. Just like Mr. Hans-Sweet Keat mentioned to all of us, that you can definitely solve problems. In his case, it's actually solving it with economics, which I think is wonderful. We need to all come together as interdisciplinary because our focus is on creating, mobilizing, and realizing innovative engineering solutions. And we definitely need to collaborate with economics. So let me go on to congratulate all of you. Please give yourself a round of applause. Singapore, once again, your leadership is astounding. You are ranked #1 again in the Asian Digital Transformation Index to be one of the most business-friendly country in the world. Furthermore, using the Global Competitive Index, GCI, Singapore ranks only second to Switzerland and jumps ahead of United States, my country, in terms of being the friendly and favorable country to be able to do business. However, I have to challenge you. You rank quite low, specifically #9, in the rung considered in the Environmental Performance Index as a clean country. And I very much, and this is one of the reasons why I am here today, is to collaborate with the IES organization, many of the folks that plan to get today's seminar, and we have many midnight calls with Jasmine, Fender, Amelia, and Leon, and numerous IES leadership because of our commitment to lead a supported and coordinated effort to embrace sustainability and circularity. This is why I like to help. And I'm still here in the middle of the night. Especially, I actually lost my father last week. I am committed to your success. Singapore used a lot of technology in catching attention as a thought leader. I have no doubt you will be very successful in terms of your digital transformation. However, you have to ask yourself, and myself as a Global Climate 50 member, I clearly see you have room for growth as you approach Industrial 4.0, that you will embrace circularity. As I said, you have one of the brightest minds in residence, and we need to make him teach us and work harder. This is an illustration that I created for the data center industry and with the UN SDG program. And according to the latest IPCC report and the global climate experts, it shows scientific evidence that we cannot drastically reduce carbon emission. If we don't do that, our planet shall face more catastrophic consequences. Hence, it is time for all the engineers around the world need to come together. I am a net zero cloud infrastructure inventor, and I work with many clients such as Google, Microsoft, Equinix, Tesla, Apple, Facebook, Goldman Sachs, Akamai. Many of them actually will be speaking at the WES and the NED event. And currently at InfoPrime, myself and the inventor, Dr. Alberto Ravani, who will be speaking later today with Microsoft, leading the EU Clean Energy Standard. And we like to embrace all of you in terms of setting the clean energy and circularity standards by having Singapore participate so we can avoid, remove, and reduce the emission of 53 million tons, according to some of the report done by Dr. Saram Ramakrishna and his team at National University of Singapore. Very impressive work, I have to say. So using the net zero design, which I have done over the last 14 years, throughout the ICT and data center, we were able to remove and avoid and reuse the emission. And I've done so as a COO for eBay International, supported over 17 countries and over multiple gigawatts. The Singapore grid is not yet green 24/7. Hence, we need to have supplement technology, and a challenge for all of you out there driving engineering to come together. This is a slide that I like to share, and I'm sure many of you might have seen it before. The importance of this is the following. I'm a computer scientist, and if we actually do not work together, we will be destroying the ecosystem of this 9 planetary boundaries. And once we've done so, it is an irreversible impact that we will have that destroy the stability of our planet. And crossing these boundaries is the primary reason and the scientific evidence to show why we have climate change that could negatively affect species and destroying a biodiversity. Hence, it causes the risk of our environmental change. We must, as a humanity, mankind, come together to set up science-based targets for us going forward. And there are many initiatives, including the UN SDG goal, the WWF, the UN Global Impact, the World Resource Institute. Many global scientists are now working together. And I very much like to embrace Singapore in all of our effort to come together. Thank you very much for actually having me today. I know this is a short presentation, but I encourage you to also attend the NED workshop that I will be doing, to giving a 60 minutes on a step-by-step approach about the pragmatic way of how we can remove, avoid, and reuse emission. And by doing so, we all will be promoting one very important concept called energy ethics as a global citizen, and be responsible for not just a country pledge, but our personal pledge to embrace circularity towards clean energy. We hold ourselves responsible. Every session like this session today or another conference, we should be running on clean energy for every kilowatt per hour consumed. I challenge us, all of us, next year, we'll be running 100% 24/7 for WES 2022 to be on clean energy and to embrace circularity as taught to us by Professor Saram Ramakrishna. So thank you for having me, and let's have a Clean Energy Singapore Internet Minute for the next year to come. Thank you.
Thank you, Ms. Susanna Cass. Next, it is my great pleasure to invite Dr. Biki Bangu, President, Southeast Asia Pacific and South Korea of Rolls-Royce Singapore Private Limited, to share with us on accelerating technology evolution through innovation, talent, and collaboration.
Distinguished speakers and guests, ladies and gentlemen, it's an honor to be here today at the World Engineers Summit today to share with you my thoughts on accelerating technological innovations and evolutions for a greener future. Rolls-Royce is a global power group committed to delivering clean, safe, and competitive solutions in the civil aerospace, power systems, and defense business. Since the first industrial revolution, engineering, science, and technology have been the foundations for prosperity and economic growth. However, increasingly violent storms, searing heat waves, rapidly rising sea levels, along with other pressing environmental challenges faced by mankind, are calling for a paradigm shift across all sectors. This is where engineering is playing a key role in creating a more sustainable future, with the technology as a fundamental enabler for society and transition towards that future. Organizations across the world are actively looking at ways to build sustainable engineering solutions. The engineering profession faces a race against time to develop new energy solutions and systems, technologies, advance decarbonization energy utilization, and enhance efficiency of existing products and services, whilst reducing emission during this transition. It starts with acknowledging that evolution requires a strong commitment. For Rolls-Royce, we will ensure that our products and solutions we develop and the facilities we operate will be net zero compatible. We are proud to have joined the UN Race to Zero campaign. In June this year, we launched our net zero pathway and targets. And our strong participation at the COP26 further reinforces our commitment to our net zero goal. We have set clear and ambitious net zero emission targets to become a carbon neutral business by 2050. To get there, we will ensure that all our aerospace Trent engines used across a wide range of long-haul aircrafts are compatible with sustainable fuel by 2023. Furthermore, our committed goal is that all our new products will be compatible with net zero operations by 2030, and we will have reached net zero emissions in all our operations and facilities in 2030 also. As we turn our commitment into action, we must chart a clear engineering technology pathway to make sure our energy systems are greener and more efficient. Rolls-Royce has decades of experience in pioneering solutions to some of society's toughest engineering challenges. Many of our technologies and products have advanced and significantly in better fuel efficiencies and have become net zero emission compatible products that we are very proud of today. Our current aerospace Trent XWB engine is an example. Continual technological advancements have made our Trent engine 15% more fuel efficient than its first generation of Trent engines that were developed in the 1990s. Our Trent XWB engine now has the distinction of being the most efficient large gas turbine engine flying today, powering aircrafts from 6 hours journeys to ultra-long 19-hour routes. Similarly, our next generation of engines, the UltraFan, is today the largest global aero engine in production in the industry and will power both narrow and wide-body aircrafts with a significant 25% fuel efficient savings compared to its first generation. In civil aerospace, as our engine programs mature, we are putting more focus on productivity and efficiency gains, such as increasing the use of digital technology. We've also made considerable progress through the testing of sustainable aviation fuels, SAFs, that play a vital role in decarbonization of carbon-intensive sectors. On top of that, we are exploring the application of hydrogen and new business opportunities in electric flight through the Rolls-Royce electrical business. Meanwhile, novel technologies also bring growth opportunities, such as in urban air mobility, regional aviation, power generation through small modular reactors, microgrids, direct air capture, and battery storage technologies. We are making advances in fuel cells. Rolls-Royce aims to have integrated 2 megawatt of hydrogen fuel cells into operational microgrid demonstrators by 2023, enough to power roughly 400 homes or a small community. We believe this project will yield further insights into the integration of multiple power sources in a microgrid application. We see technology as a key enabler for success, and we have in our research pipeline additional low and net zero carbon technologies under development out to 2030 and beyond. Going forward, we will continue to boost our research and development expenditure towards low carbon and net zero carbon technologies, moving from approximately 50% of our gross R&D spend today in these areas to at least 75% by 2025. Against the pressing need to address climate change, strengthening collaborations with other MNCs, SME, governments, and academia is imperative to allow us to collectively co-create solutions. Cross-disciplinary collaboration has always been integral to Rolls-Royce's approach in innovation and solving complex issues. Rolls-Royce recently announced our partnership with Boeing and World Energy to carry out the 747 flying testbed aircraft with 100% sustainable aviation fuel on a Trent 1000 engine. We have partnered with Airbus, German research center DLR, together with Nest, launched the first flight emission study using 100% sustainable aviation fuel on a wide-body commercial passenger aircraft. In March 2021, Rolls-Royce and airframer Tecnam joined forces with Widerøe to deliver an all-electric passenger aircraft for the commuter market, ready for revenue service in 2026. That same month, we also announced our collaboration with Vertical Aerospace to design our groundbreaking electronic propulsion system to power its flagship urban air mobility aircraft. The electrical power system will be integrated into the piloted all-electrical vertical takeoff and landing vehicle, which will carry up to 4 passengers for 120 miles at cruise speeds of over 200 miles per hour, and this is on course to be certified by 2024. To support the development of sustainable aviation fuel, we are partnering with companies like Shell to advance the use of SAF in aircraft, develop more sustainable fuel processes, and, more importantly, speed up the SAF production. Only yesterday, Rolls-Royce announced our advances with SMR small modular reactor to bring forward and deliver at scale the next generation of low-cost, low-carbon nuclear power technology. In all of these technologies, we must acknowledge that exceptional engineering talent is key to accelerating innovations that will take businesses, societies, and economies forward towards a net zero future. To build a strong talent pool, cultivating engineering talent with deep subject domain expertise, combined with the ability to thrive in a diverse team, is vital as the industry transforms. The key to capability and talent development is partnership. Investment and infrastructure, together with supporting in partnership with world-class researchers and technical experts to facilitate rapid prototyping and product development. This is what Rolls-Royce has been doing with the research and technology ecosystem around the world and in Singapore. Together with Nanyang Technological University, we have established the Rolls-Royce at NTU Corp Lab. The lab focuses on our core research areas of data analytics and complex systems, electrical systems, advanced repair and materials, Internet of Things, and manufacturing technology. And it's a conducive environment for strong collaboration between company fellows and NTU professors. It is at this type of environment, the Corporate Lab, that Smart Discovery was developed. This is a suite of technologies that incorporates AI, enabling subject matter experts without data science skills to be able to perform data analytics themselves, thus delivering solutions more effectively and confidently. Rolls-Royce at NTU Corporate Lab is today one of the largest amongst Rolls-Royce University technology centers. Globally, we have partnered with 28 of such centers, and our relationship with universities have led to knowledge sharing across domain experts, new innovations, and development of local talent and capabilities. We are also a founding member of the Advanced Remanufacturing and Technology Center, the ARTC, an industrial collaboration between A-STAR, NTU, and National Research Foundation. ARTC is a testament to our dedication to collaborate and bring state-of-the-art technologies into industrial production whilst helping to develop the local ecosystem. Together with A-STAR and ARTC and SAISL, which is our MRO joint venture with SIA Engineering Company, we collectively established a Smart Manufacturing Joint Lab to develop the next generation of aerospace manufacturing and MRO capabilities, enabled by advanced processes, automation, and digital technologies. One of the innovations from the Joint Lab is a partnership with A-STAR and local SMEs, Zinco Technologies and Sysmatic Global, on a solution utilizing an array of cameras and specialized lighting to capture detailed images of a jet engine fan blades to improve product inspection processes and significantly reducing the time taken for this process to be carried out. Engineering is a discipline that requires effective partnership and teamwork. In supporting the development of talents and teams with deep domain expertise and broad exposure, we're also witnessed what innovation this can unlock for us. In our continuous effort to drive diversity in the workforce, we have made public pledges to provide more opportunities for females in engineering and technology sectors. It is also important to create a team environment in which every employee feels that they can be at their best by encouraging inclusion and diversity. Developing new technologies and capabilities are essential to a strong future. The talent that we must advance should not only focus on hard technological expertise, but also on critical soft skills that can spur innovation further and facilitate cross-pollination of ideas across diverse teams. The emphasis within the education system to recognize the dual importance of these skills has to be greater than ever to develop the next generation of talent. At Rolls-Royce, we believe in STEM and STEAM, and the education that's required to propel early interest and support talent development in the future benefit of our business, industry, and economy. In Singapore, we have been engaging with students through schools and organizations through the IES, sharing and progressing towards the world of low carbon and net zero technologies through presentations, discussions, innovation projects, reinforcing the connection between classroom and the outside world. Globally, we have Rolls-Royce STEM ambassadors who are actively involved in education programs, and actively around the world, we're hoping to inspire 25 million people by 2030. Our environment today requires deep expertise, dynamism, and collaboration across diverse teams, industries, academia, and governments to drive collectively the next generation of innovation. ASEAN remains at one of the most vibrant growth areas in the world with a young, diverse talent pool. The movement of goods and connectivity of people form the backbone of the region's economies. Our challenge is to ensure that the region quickly gets back on its path of economic growth and prosperity following the pandemic, and to do this sustainably. As we foster together stronger collaborations, local and regionally, we'll be able to lay stronger foundations to tackle global challenges together and accelerate technological innovations for a net zero world. Thank you for listening.
Thank you, Dr. Bangu. Thank you so much, Dr. Bangu. We'd like to invite you back to your seat. I was quite taken with Dr. Bangu's speech, especially the moment when he mentioned STEAM. Now, for those of you, everyone is familiar with STEM, but STEAM includes arts within the framework of science, technology, engineering, and mathematics, and the combination of soft skills together with the hard technical skills to make sure that holistic innovation takes place within the workplace and within the education system. I found it to be rather insightful. Now, our next plenary speaker for today is Associate Professor Ong So Kim. Associate Professor Ong So Kim is of the National University of Singapore's Mechanical Engineering Department, and her research interests are virtual and augmented reality applications in manufacturing, ubiquitous manufacturing, assistive technology, and rehabilitation engineering. Let's welcome her.
Hello, everyone. Good morning to everyone. And thank you for having me here. And my topic will be on digital twin and augmented reality in manufacturing. And as highlighted in DPM's Haing's opening address just now, that the Singapore effort, the government's commitment to advance manufacturing in Singapore is enshrined in the 25 billion RIEC 2025 plan using smart and intelligent technologies. And the technologies I'm going to talk about now will be digital twin and augmented reality. So specifically, it will be digital twin and augmented reality in transforming manufacturing engineering. And sustainability is not just about a sustainable product. Sustainability is about productivity, about efficiency. If we can be productive, if we can be efficient, that is sustainable development. So imagine if you have a piece of equipment that you need to ask for manuals, or you need to flip through manuals, or you have to ask offsite experts for help. Now, AR can come in. AR can give you information, overlay digital data onto the real world to give engineers, workers, managers immediate access to vital information anytime, anywhere. Okay. So AR actually has a potential to provide far more value in manufacturing engineering than what most people think. A lot of people think that AR is Pokemon. AR is not Pokemon. AR is more than that. It can add a lot more value to manufacturing engineering. It can integrate digital information in ways that engineers, managers, and workers perceive the real manufacturing world, and enabling them to seamlessly use that information to guide them in their decision making, in their operation, in their choices. And that actually is seeing and interacting with information in a very new way. So, AR is actually connecting human and machine. So it's an innovative, creative human-machine interface. So connecting human and machine is through AR is actually changing the face of industrial manufacturing. And actually, it's actually most effective when you're actually connecting operators, managers, engineers to your asset. So you have many assets on your shop floor, on your industry, on your offshore site, for example. And actually, it connects all those to your human, your engineers, and that visually allows you to see, visually indicate the condition of your workpiece, of your machine, of your shop floor, of your supply chain, for example. And that actually is very effective, and AR is most effective that way. So for example, this is actually Ford Motor. Ford Motor is actually using AR to develop prototypes, and you don't even need a very costly physical prototype. Unlike previously, where we have to actually waste a lot of resources developing many physical prototypes. So AR actually comes in the sense that you can actually build very innovative prototype, share it with your stakeholders along the entire life cycle process without having to build costly physical prototype. Now, another aspect here is machine builder, for example. Many machine builders are now actually incorporating all of this augmented reality manuals into their equipment. So you can actually overlay instructions on your machinery, on your product, for example, and that actually increased productivity by as much as 40%. So what AR is, AR actually fundamentally allows humans, you and I, humans and machine to team together. Previously, we couldn't actually work or team together with a machine. We could talk to a robot, for example, but we couldn't actually team with a machine. But AR allows you to do that. So it fundamentally allows human like you and I, a machine, to team together to achieve something that none of us could achieve alone. So AR actually increases manufacturing efficiency and the workforce productivity. Now, another aspect that comes in is, now, think about a motor, think about an offshore turbine, for example, a wind turbine. Think about a lot of expensive equipments out there where it may not be feasible to put in a sensor, to put in a sensor somewhere to measure, for example, the temperature, the humidity. And sometimes it's impractical to perform extensive trial and experiment on an equipment or a machine. Now, that's where digital twin comes in. So you don't even need to put a sensor. You can actually perform your finite element modeling, finite element analysis. You can model the temperature changes, and that actually doesn't require the need to put physical sensors anymore. So digital twin can perform multi-physics, multi-scale, probabilistic simulation of a very complex product, a complex system, which functions to mirror the life of the corresponding twin in real. So your physical asset in real. So how does digital twin comes in? So digital twin essentially will improve product or improve enterprise productivity and efficiency, and reduce the cost and time, because you could now actually model your entire system. You could now do whatever that is not possible, putting in your simulation, your FE analysis, your stress and strain analysis, and then you could even use your historical data. Using your historical data, using intelligence like, for example, machine learning, you could then predict. You can prognosis, you can diagnosis, you could then predict what will happen, and you can model it. And you can actually know what will happen before the actual physical asset fail, for example. And the physical asset data that comes back into your digital twin will actually fit into your system to refine your digital twin model. And that two-way communication will make things efficient and productive. So digital twin provides a very unique way to reflect a physical entity in the digital space, the digital world, with respect to shape, with respect to status, with respect to motion, for example. And it can assess your ongoing state, as I mentioned just now. You could diagnose historical problems, and you could project future trend. So this cyber-physical integration is what digital twin will provide you. And with this cyber-physical interaction and this digitalization of with the digital space, it helps in the transfer of expert knowledge, because expert knowledge can now then be digitalized. It can then be transformed. It can then be transferred across an entire enterprise. So, this is actually what has been shown in the Siemens factory in Germany. Siemens already has such a digital twin of its entire shop floor, where you could have interactive monitoring and control of the shop floor. And that actually will revolutionize the industry, because you can then know what is happening on your shop floor, optimize it before, whatever actually a machine breakdown. Now, another aspect that comes in is this: a real-time digital twin of the production environment actually connects activity in the real world to the manufacturing execution and planning system. And what happens is that makes the real world processes involving moving asset visible and measurable. Previously, you can't see them because they are on the shop floor, they are in the pipeline, whatever. But because of digital twin, you could now see the virtual worlds become a blueprint for the physical world. You can see your asset now visible, you can see it measurable. And that is the value that digital twin can add on. So through digital detection, measurement, the product attributes, the operating status of your machine, the operating status of your shop floor, and other data will be fed back to your digital model, your virtual model. And that actually achieve a two-way data transmission, which is actually a very important aspect of digital twin, because this transmission, the physical data, the data from your physical asset being transferred back to the digital model will be mirror on the digital model. And whatever happened in your digital world, your digital analysis, the simulation, your analysis, your prognostic can be transferred back into your physical asset, which is what is happening here. For example, here in the lower portion, the Advanced Forming Research Center has actually used digital twinning to help the whiskey industry reduce inventory waste when filling it. So that actually is a very innovative way of using digital twin. Now, for example, roast right. This is different from what Mr. Binky mentioned just now. This roast right has actually used digital twin in manufacturing, in aftermarket, and in the repair processes. And the operation data is used to enhance the accuracy of the twin. Now, likewise, digital twin of an MRO shop floor, it has actually been used. For example, you can see here. So it actually has been used via the installation of sensor, IoT, and the asset can then be tagged, can then be traceable. So this again is another value add of digital twin that comes in. Now, one thing to note is that, or the main thing about a digital twin is that it must have a physical asset. So the main thing that a digital twin has, which a simulation model doesn't have, is the real-time connectivity to your physical asset, system or process. Unless you have a real asset, you cannot have a digital twin. You only have a simulation. So that is where the digital twin comes in. Okay. So to sum it, as I'm going to sum it, simplicity is actually the charm of augmented reality. So augmented reality is a smart, intelligent technology that comes in. It's very simple. You create your own content when required. And that's what's so attractive about augmented reality. Now, imagination is the appeal of digital twin. Why do I call it imagination? You could have your entire supply chain worldwide, but imagination is where digital twin comes in, the appeal comes in, because you could then visualize your asset moving around worldwide. So that is the imagination, and imagination is the appeal of digital twin. So to achieve the invisible, and that's what's so attractive about digital twin. Okay, now integrating augmented reality and digital twin, that can give managers, engineers, workers, human like you and I, critical information just in time, anywhere. And that will lead to a digitally connected workforce and enterprise, which is well equipped to keep production line running with fewer interruptions, and also lead to reduced downtime for your equipment failure, your shop floor failure, a lower operational cost for maintenance activity, and increased business efficiency. So digital twin and augmented reality integrated will revolutionize the manufacturing industry. So you can work faster. You can solve your shop floor problem daily. You can access data easily with augmented reality. With digital twin, you can prevent errors because you can then do prognostic. You can reduce your production downtime. You can cut down maintenance costs. You can even use it for training workers who are offshore, training engineers who are remotely located. You can even make better informed decisions with your digital twin simulation and analysis. So AR and digital twin integrated will revolutionize the manufacturing industry out there. And with this, with the RIEC 25 billion, with the government's commitment to helping the Singapore traditional manufacturing industry move toward Industry 4.0 with smart, intelligent technology, augmented reality and digital twin would be two key technologies that our local industry can use to advance themselves in Industry 4.0. And that's all I have. Thank you.
Thank you, Prof. Ong So Kim. Now, I especially like that part when she mentioned is to achieve the infeasible. It's not like what the solution the digital twin can bring, it is not possible. That's not the case. It's not feasible. It may not be cost effective. It may take too long. It may introduce more problems. But to do something infeasible and then find a solution and then implement what is possible, that I think is one of the true values. And I thank Prof. Kim, Prof. Ong So Kim so much for that. Our next plenary speaker is Professor Paul Teng. Professor Paul is the Managing Director of NIE International and the Adjunct Senior Fellow at the Center for Non-Traditional Security Studies and RSIS, both at the Nanyang Technological University of Singapore. He is also concurrently the Senior Advisor for Agri-Food to A-Star Singapore. Let's welcome him for his presentation on technology-enabled food security for a city-state.
Thank you very much. It's a real privilege as a bioeconomist to join this WES and speak about technology-enabled food security. And very appropriate, by the way, just before lunch. Now, when we talk about technology-enabled food security, what we really mean is translating that into a use case for precision farming or smart farming. In other words, farming which really optimizes resources, land, labor, water, energy to increase productivity, particularly using a set of technologies. And Singapore, as a small country that imports 90% of its food, has particularly strong arguments to use smart farming to help us in our food security. At the national level, we see particularly importance because of the supply chains, as was mentioned by other speakers, really, where certain technologies can help us ensure our supply chains. But more importantly, within Singapore itself, at the farm and farm enterprise level, technology is equally important for us to not just stabilize production, but also increase productivity. And of course, now, more recently, we're talking about household food security as well, and the use of digital technologies and engineering, in fact, for households to ensure food security. This picture in the middle shows a kind of a cabinet that was designed in Singapore to allow folks to use and grow vegetables in their sitting room as part of interior decoration. And it's a fascinating business model because the inventor will bring this cabinet to you, you buy it, every month he replenishes the vegetables. So all you have to do is just harvest. But on a serious note though, we have many kinds of urban farming in Singapore. In particular, I want to kind of point you to the kind of last 3 bullet points here: the specialized urban food production, which I'll talk a bit more about, large-scale agro-enterprises, and also multifunctional farms. So all of this, in fact, can be smart in different ways. We're also fortunate that there are a lot of enablers in Singapore put in place by government, by the private sector, for us to really practice smart farming. It's not just policies, regulations, and instruments. It actually goes beyond that. We've got a very strong investment community here in Singapore, venture capitalists, sort of the biggest in the world. And we're also seeing an emergent agri-food ecosystem. But critical to all this really are disruptive technologies. I think we're increasingly starting to appreciate that. In this particular century, disruptive technologies are so key for us to maintain food security, especially in city-states. Here are some examples very quickly. You know, of course, we've heard quite a bit about digital innovations now, and they're starting to have a major impact on farming in cities and on farming in the countryside. AgTech, you know, one of the fastest growing investment areas in the world, actually. FinTech is the other one. Internet of Things is becoming quite common now, both for indoor farming and also for rural farming. It's quite amazing to see, you know, smallholder farmers in India, Africa, you know, basically have access to online platforms, you know, to help them be part of the supply chain itself. Then, of course, talking about supply chains, you know, it's not just the hard technologies, also the soft technologies. And here's where I think Singapore is actually taking quite a big step into this area. There's a new company called the Food Security Exchange that's helping us to do early warning on supply chains. And as you know, Singapore imports food from over 170 countries in the world. So we have to be very cognizant of what happens in those source countries, in the processes of transporting food from those source countries to Singapore, and how we can, in fact, much better manage the risk of disruptions to these. So all very important components of our food system in Singapore. Now, the other area that Singapore wants to excel itself, and the government itself has put in a lot of investments here, are what we call innovations in unconventional farming. The first of these is really nothing new. Vertical plant factories with artificial light. Japan is quite a pioneer in this. Now, PFLs, there are over 400 of these in Asia now. I think we can be very proud that in Singapore, we're doing some really innovative stuff to enhance these indoor plant factories, okay, with new plant sensors, new IoT systems, and so on. And there's also a lot of work going on, not just on vegetables, but also indoor aquaculture. Because apart from vegetables, rice, fish is the other important element, I think, in the Asian diet. Yeah. So we're seeing a lot of, basically RAS systems, recirculating aquaculture systems with all kinds of IoT, enhancements in them. Also packing them with proper genetics and breeding new kinds of fish, which also requires engineering, by the way, robotics and so on. Yeah. So unconventional farming is a big drive in Singapore. And then, of course, something else that we're very well known for in Singapore is so-called novel food. Some of you probably are aware of the fact that Singapore was the first country in the world last December to approve a cellular chicken nugget for sale. Okay? And that really has opened the way to a lot of investments, both in the technology area, but also in the enterprise area, to make Singapore a key player in this whole new space of cellular meat, cell meat, lab meat, whatever you call it. Yeah. But beyond that, our drive in the novel food, which requires lots of engineering, also this with microbial proteins, plant-based proteins, and more recently in terms of insect proteins, the extraction of eatable insect protein, appropriate amino acids, from the raw insects themselves. Okay. So these are all areas that we can't do without technology, basically. Bioreactor, precision fermentation, they're all based on engineering technology. Now, lastly, though, a bit of a push here for Singapore. Singapore wants to be a leader in this whole space of tech-enabled farming, tech-enabled food production, especially making use of cities, okay, and making sure that cities are not viewed as a problem, but really as an opportunity for us to contribute to food security worldwide. So these are just some initiatives in this last slide that illustrate what is happening in Singapore. Of course, we always appreciate the fact that Singapore is an island state, like most other big cities. There's always limitations of space, land and space, water, and of course in Singapore, labor as well. Yeah. But so these initiatives will position us, to really make cities and city-states an important player. Okay, and again, just to end off with it, technology is quite key together with financing from VC entrants in Singapore. So with that, thank you very much for listening, and I look forward to some potential questions. Thank you.
Thank you, Prof. Paul Teng. Ladies and gentlemen, we've heard from our 4 plenary speakers, and now it is my pleasure to invite our moderator for the session, Prof. S.K. Cho, on stage. Prof. Cho, please. I'd also like to invite on stage Dr. Biki Bangu, our plenary speaker, and we'll be inviting our digital plenary speakers as well, and they will appear on the screens in front of you. All right, it looks like we're all here. Prof. Cho, over to you.
Right. Good morning, everybody. And we have had the pleasure of listening to 4 eminent speakers who brought to us diverse opinions and experiences. And it's such a rich mix of ideas. And I'm just wondering whether we are going to have enough time for us to mine the minds of the 4 speakers. I only have Dr. Bangu here with me, but the other 2 or 3 speakers are online. So you are free to post questions. And we first had Ms. Susanna Kass, right, who spoke to us about sustainability and also the circular economy. And then, of course, that was followed by Dr. Bangu here, who spoke to us about innovation and technology and fuel economy of the Rolls-Royce engines. And of course, then that was followed by So Kim here on screen, who was very excitedly talking to us about augmented reality and the digital twin, for instance. And finally, we got food security, okay, from the expert, Dr. Paul Ting himself, okay. So, all right, so I'm going to see questions coming to me on the screen. For those of you who are yet to ask questions, please feel free to pose the questions. So, but before I see those questions, let me just pose a very simple question here, and that is a common one, because we are all engineers. Okay, this is the World Engineers Summit. I think at the top of our mind, really, is that where do we stand as engineers? How are we prepared to meet the challenges going forward, post-pandemic and into the future? Low carbon and the challenges of climate change and so on. And where do we get started? So I would like to open this discussion. First of all, maybe I should allow Susanna to come in first, a quick one, and then followed by Dr. Bangu here, and then the Sokim herself could come in, and then of course Paul, and then while we gather the questions as they roll in, okay? So yeah, Susanna, over to you.
Thank you. I would say the first step is our mind. In the ICT sector, when we are embracing sustainability, clearly I have been working with leading pioneers such as Google, Microsoft, Apple, Facebook, and many others who have businesses in Singapore, have already taken the step towards a carbon-free and an emission-free and a net zero future for a while. Personally, myself, have been building many net zero data center that basically have zero use of fossil fuel and maintaining 24/7 operation with 5 nines, 99.999 uptime, and generate zero emission, and then we also reuse the waste. What we have done is we need to do more to pick up the pace in the following decade. So being a computer scientist and engineer like all of us, I believe the technology is actually available today in terms of reaching net zero, but it is the mind, the human mind, that are still stuck to the old world of linear economy, and hence we are not accelerating in terms of using innovation and technology, be able to embrace circularity in the digital transformation. So I challenge all of us as engineers to take the lead to invert the status quo, to do a baseline of where we are today. Once you have calculated you have 53 or 52 million tons of emission, let's develop a plan to execute towards that so we can actually take step-by-step pragmatic approach in terms of addressing sustainable development going forward. Thank you.
Big, you want to say something here?
Thank you, Prof. I think the first step for us to take is understanding and recognizing that there is no single silver bullet. There's no single technology that will solve the crisis that we're in. It's a combination of technologies across industries and societies. And also recognizing that it is no single entity that's going to do this either. It's a combination. This way collaboration becomes really, really key. You know, we're seeing partnerships that we thought was unimaginable. Aerospace working with oil and gas sectors, for example. We have to look at the challenges together. We have to bring our suite of capabilities together. We have to link much more strongly across geographical borders as well, to be able to collectively, with the same purpose, the same vision of net zero carbon, and getting and really starting at that place of combination of technologies and collaboration and co-creation across geographies will be a great start, which we're seeing great examples of.
That's okay. What you?
Yeah, where do we stand as engineers towards sustainable society? And one point that DPM Heng mentioned just now is design for maintainability. And I think design for maintainability is actually a very important concept. And design for maintainability would be the way that we can move forward toward a sustainable society. And that should start as young as primary school, secondary school, all the way to IHL. And design for maintainability should not just be for infrastructure. Design for maintainability can be designed for maintainability for a product, making a product upgradable so that we can make the product last more than one life cycle. And that will reduce our waste, and that will make better use of our resources. So design for maintainability for product, for process, for infrastructure. And starting as young as our primary schools, we can incorporate such concept into our curriculum in our primary school, our secondary school, and that will actually inculcate the mindset of sustainability in our entire society, in our entire Singapore population. And that's where I think that we as engineers can come in to work together with the educators in incorporating such information, such technologies into the curriculum for the entire education system. Yeah.
Right. Paul.
I would kind of add by saying that I really like what the previous speaker said about there's no silver bullet approach. I want to add to that and say that, many of the problems we deal with today at the global level are really wicked problems. Okay, so this nexus of climate change, sustainability, food security, you can't solve one without tackling the other, basically. And that's why I think engineering plays such an important role. Okay? In the 20th century, one of the biggest disruptive technologies to produce more food sustainably was mechanization, tractors and so on, Now, in this particular millennium, we're now seeing the emergence of new technologies through engineering that allow us to factory farm food without emitting greenhouse gases, right? So you're actually tackling a set of wicked problems with simple technologies, okay? So I'll just stop there. I think, yeah, engineers definitely have an important role to play in solving some of these big problems. Yeah.
Well, thank you. I mean, we have been hearing a lot about how engineers and scientists and researchers should come together, okay? Break down walls, so to speak, and work together so that the results will be bigger than the sums of the parts, for instance. But are we tackling something that is at such a high level that to many of us engineers, we are faceless mostly? Are we able to come in at a bite-sized level and do those actions well enough so that there could be an integration that's going to be effective, efficient, and at the end of it, contribute towards that sustainable development of the whole world? So this question I could pose to all the four speakers, okay? My first, of course, I would go back to Susanna herself because she talked about sustainability and the economy. So Susanna, a quick word on this. What do you think? Are we at too high a level? Are we able to understand our responsibility, or do we have to have an umpire somewhere that will perform that role of bringing people together and also to be able to break down some of these walls that are compartmentalized?
Indeed, it is it is actually an interdisciplinary topic when it comes to sustainability. I have to argue that it is not just engineering, but it also brings together what our guest of honor mentioned earlier in terms of the economics part and definitely the policy, right? So as computer scientists or engineer, technical people, we have a tendency to develop data boundaries in terms of the scope of our statement of work or our design. And I myself have worked with many inventors, and myself being one, in terms of doing net zero design. So we identified the specific, not necessarily I would say problem, but more an area that we felt it is important to address. And we set up the attributes and a variable, and by doing so, we then set up the experiment. So I think one of the key things for sustainability for Singapore or the engineering community is to have a common standards and a common approach towards measurement of sustainable development. Such as how much how much carbon and fossil fuel of the grid that you're going to be able to green over a certain period of time, or how much emission that you're actually emitting that you can take steps towards avoiding, reducing, and perhaps reusing it. So taking small chunk of the problem that you are responsible for and then working collaboratively with counterparts in other part of the world or other disciplines and be able to create a strong joint is actually how we build the data center through the life cycle that I shared with the team earlier. And for any of you who might be interested in how we actually create these net zero data center, I will be glad to share a white paper and a technical specification, because that's basically what we're promoting is clean energy standard. And my colleagues and around the world, we have done it in 17 countries and in gigawatts. So don't pioneer on our pain, but improve on the work that we have done. That's why I'm here this evening.
Right, thank you. Dr. Bangu, I mean, you are in the thick of things. You're in innovation, deep technology, and you, before you wrapped up, you were talking to us about that fuel economy, the new engines that you are developing that can save energy, okay? Now, are we doing enough? I mean, you need to be able to work across boundaries, okay? So in a Singapore context, what lessons are there for us to learn? What are the key ones? Yeah.
I think one of the strengths of Singapore is that we plan really well in the long term, and we plan for the future. And sustainability is definitely one of those agendas that we need to plan for the decades and decades yet to come. And when we look at successes that we've seen where having a vision and pledge is a great place to start, and many organizations have done this over the last 24 months. But the next step is really important. What is the roadmap, and how are we going to get there? And within Rolls-Royce, we went and communicated our roadmap several months ago, which illustrates what we're going to do in 2 years' time, what we're going to do in 9 years' time, what we're going to do in 15 years' time, and where we will land by 2050. And this is impacting our technologies that we're investing in. It is showing how our products and services will change. It will show the new partnerships that we will have that we've never had before, and bringing our people together. So I think what we've started doing here, and DPM mentioned the RIE 2025, it's really encouraging to see a huge focus on the research innovation enterprise over the next 5 years will be on sustainability. And now it's our opportunity of organizations in Singapore to be able to see how you tap into that and how you contribute to that sustainability agenda. And it comes to the partnership with academia, it's partnership with other organizations, it's partnership with SMEs. We have to look across the whole value chain of our activities. It's not just, I'll sort of look at this focus area and someone else will look at the others. We have to look at sort of all the way from logistics to manufacturing, through products, to services, through life cycle. And then really see what are the technology and engineering solutions that can enable that journey. So having a clear roadmap is critical for us to be really focused on now.
Thank you. Well, So Kim, you were very enthusiastic about AR and DT and so on. Are you making it sound so simple, so attractive? Do we understand what you're talking about? I mean, if you give us the first 5 minutes, it seems it's so intuitive, right? But if we were to go deeper into it, I'm sure it's going to be very complex. Right? Can you break it down to something very simple for us? That is to say, if I was an engineer, I'm in a factory or in a manufacturing context, is there something that I can do? Or should I be nudging my superior or supervisors and be taking them to, the big screen to explain to them what this is all about? Or are they already in this environment of AR and DT, and that is already in motion? So there's no concern of ours, but just to continue in our upgrading process in the manufacturing floor. So my question really is, is it something that is already so intuitive, or do we have to go deeper into it? And what kind of preparedness do we need to have? You are muted, So Kim. Yeah.
So the bigger player themselves, the MNC, they're actually already embracing augmented reality and digital twin. And it's actually the small, medium enterprise that have not actually adopt augmented reality and digital twin. And it is intuitive. And I feel that the small, medium enterprise and industry, they will be more motivated if they can see real benefit, but they will need to overcome hurdles like computing skills and technologies and IoTs and sensors and cloud computing, cloud platform, and all of this itself. So in order to get them to be there, as an engineer, we are faceless like you say, but as an engineer, we can actually move or help to nudge them along by introducing, by embracing, by using commercial tools first, using some commercial tools and apps to begin with to build such infrastructure for the company, for the industry. Now then IES can come in. So Dr. Richard Kwok mentioned itself, unity is the power of engineering. Engineers are united. So IES itself can organize workshops, can organize training courses to give engineers in the industry some head start to augmented reality and digital twin. And IES, with the support of university and research institute like ARTC and so forth, can actually come in to have more of this multi-interdisciplinary or interdisciplinary workshop that can engage our local industry, our small SME enterprises to get them involved. And once they see the real benefit and once they see something, then they will know that it is intuitive, and then they will be more willing to adopt the industry, the technologies. Yeah.
Right, thanks. I mean, before I go to Paul, okay, Paul has been in this business of food for many, many years. But what he brought to us just now caused me to think quite a bit, because are we now at a stage where we can look at food and smart farming as one of the motivating factors? Because as you know, before we became engineers, we were attracted to aeroplanes, boats, trains, and so on and so forth. These were the motivating objects or machines that enthused us really to go into engineering. But now with food, is there something there, Paul, that we need to know, because it's so important going forward? Okay, it's so important, and there has got to be a lot of injection of technology, and definitely working across disciplines. Okay, the engineers with the scientists, the biologists, and so on and so forth. So Paul, a few words of advice here for engineers. And then my follow-up question really to everybody is our curriculum prepared for that? What else has to come for the future in a sustainable world? Thanks.
Well, I'll quickly respond, Prof. Chow. Food is an existential need. I think we all know that, right? But then, as the previous speaker said, engineering as a single profession cannot solve all the problems. You've got to collaborate with others, yeah? Now, what I worry about is that sometimes we lose sight of what sustainability means. Sustainable cities, and so on and so forth, And I really hope that even as engineers, that we all go back, I'm not an engineer, but we all go back, to sort of early thinking on sustainability. Today we use the rubrics ESG, right? Now, the sustainability movement, in fact, started even before the Brundtland report. But we were more concerned about EES, economic, environment, social, much more than governance. Again, the corporations have now put governance as very key as part of their, basic credentials to sustainability. But we mustn't forget, and engineers should not forget, who are the people who actually work. Okay, it's the small entrepreneurs, it's the small farmers, and to them, the EES rubrics are so important. So I would urge engineers that, you got to somehow not use a kind of a technology push approach, but a problem pool approach. There are lots of problems out there that require engineering. Economics, for example, environmental, safety and social equity. Okay, you got to make sure that you come up with solutions that don't exacerbate current social inequities, that don't cause, in fact, economic, inequities as well, and also damage the environment. I mean, I can think of, the instance where when folks move, from organic farming to using synthetic pesticides, right? The engineers invented nice knapsack sprayers, basically. And that resulted in poisoning a lot of people in the world. Of course, then we came up with other engineering adaptations to help improve on that. So what I'm saying is that, yeah, I think engineers will continue to have a role to play, but choose your kind of use cases very carefully, listen to what others want, what are the real problems out there that require solutions. Okay? Thanks, Prof. Chow.
Right, really food for thought. The pun is not intended, but it's important for us to take note of all that. Okay. Yeah, now the question is still fairly unanswered. And that is because coming from the university, I am so used to looking at our curriculum day in and day out. The question really is that faced with this reality, post-pandemic, into a sustainable future, is the curriculum really in need of a refreshment? Something which is, let's start with a perspective from the US side. Susanna, do you have something you want to share with us? What's happening in a university in America, for instance?
Yes, so there's 2 points I want to specifically make. That is clearly happening in the new generation, wasn't happening in my era that I attended colleges 3 decades ago. Specifically, one of them is the following. We don't have any college student just get recruited into a particular major. At a few universities, including the one that I'm a big fan of, Stanford, is you actually create your major of what it's going to be. And Stanford recently just created a school of sustainability. We ourselves are a research institution, and we are standing humbled among other universities around the world, many prestigious ones such as National University of Singapore being one, and there are many others. We actually enabled the future generation and a bright mind of our students and the faculty to collaborate a new major specifically in the field of sustainable development. Rather than trying to adapt, because the field is so new and we genuinely need to have bright mind to create a new curriculum going forward. So to answer your question, I'm really a big fan of enabling the bright mind in the intellect, be able to come together to create a new major in sustainable development. Secondly, it is not about just research and development or being in school. We actually enabled those who are in school. I think life is actually a learning journey by itself. We also enabled the students who may be taking a full-time study to also have the opportunity to interact with commercial companies for them to really have life learning experience. And that's basically where I come in. I connect many of the students across, frankly, multiple countries and continents to be able to come together to do a net zero and a circular design or a measurement in terms of what might be some of the new measurement that we should be doing in terms of building a net zero infrastructure, be it transportation or be it a cloud or edge computing. So those are the 2 things I've identified are quite innovative and is quite common in the US right now, except that many of us, we still haven't met each other because many of the sessions are all done virtually for the past at least 18, 20 months. And it's getting a little bit kind of old for all of us. So we want to have a chance to actually have hybrid events starting and possibly get together, when it is safe to do so.
Vicky, your experience really, I mean, not just Singapore, but the UK, Korea, the Asia Pacific. What do you think? In terms of training, curriculum, how fresh are we in terms of preparing our engineers who go out into industry?
I think we're putting a little bit too much pressure on universities here. It's not a sustainable technology that's going to solve the problem. It's technology for sustainable applications. if you look at wind turbines, at the heart of it, the technology is electrical machines, power electronics, energy storage, which is deep domain expertise. At Rolls-Royce, what we look for in our technologists and engineers are T-shaped engineers or technologists. So T meaning the vertical part is the deep domain expertise, and then the sort of the top is the broader experience and the exposure that you have. And this is through, it becomes a responsibility of not just the university, but the industry. How closely are we linked through into the curriculum to provide our inputs? And we do that with many of our partnered universities, and we do provide inputs into the curriculum. But then it's also through internship. It's also the individual's responsibility to sort of see how they want to broaden out whatever sort of top hat they're looking for on top of their domain expertise. So I think the curriculum it's designed to give the domain expertise. We can perhaps focus a little bit more on application to use some of this expertise to go towards the applications of sustainability. But it's bringing together industry, academia, individual responsibilities, and it's not just a sole university responsibility.
Okay, thank you. The clock is ticking down. We have about a minute now. I'd like to, now is there I can't see any question now online. Perhaps it's hidden away from me. But is there anybody in the audience that might want to raise a question to the speakers up here on the panel? Anybody? Is there somebody there who would like to say something? Otherwise, I'll have to step in and ask another question.
He's looking for a
You
mic.
got about a, yeah. Come on. Yes, take this one. Come, Mervin.
Okay, so the question is on the disparity between developed nations and undeveloped nations or lesser developed nations. With such a great disparity in ability across different geographies, how do we ensure that that same level of sustainability could be introduced across the world?
Right, the speakers, have you caught the question? Quick comment only. Okay, quick comment, a few seconds each. We are now down to 0. We start with Susanna, a quick one. An answer to that?
In the UN SDG program, it might be surprising to you what I'm about to share. The developing country actually are more sustainable than the developed country, which technically America considered to be a developed country. But in many regards, a developing country, because they are constrained with resources in the first place, so hence they have to be sustainable for them to survive. And from the data perspective, most of the developing countries, frankly, are way ahead in terms of the pragmatic approach in terms of addressing sustainable development. It is anti-intuitive because you assume that the developed countries have more resources and more economics in terms of currency, but they have bad habits, and oftentimes the policy gets into the way. Then pragmatically, what you need to do in terms of embracing circularity, for example, and measuring themselves to be able to survive another day.
Vicky, what do you think?
It's precisely what the COP26 at the moment is addressing. And I think that 3 focus areas to bridge the gap would be access to green financing, transfer of education, and technology.
Okay. So Kim?
Yeah, I think to achieve equal sustainability may not be possible, but as an engineering educator, I feel that education will be a key approach towards achieving more equity in sustainable, both in developing country and developed country. But of course, it's a multifaceted problem. There are policymakers coming in, there are financial industry coming in. So I think it would be difficult to achieve equal sustainability. Yeah.
Okay, Paul, you have the privilege of giving us a final take on this, Paul.
Frankly, I like what Susanna said very quickly, I think a lot of the unsustainability that we see today has been caused by the developed nations. I don't mean to be provocative here, but for the solutions, I think we need to look to the developing countries to come up with solutions much faster. Take one area, food waste. We know from a lot of data that there's much less food waste in developing countries than in the developed nations. So who do you tackle? Is it through technology, through education, whatever it is, yeah? So in balance, I think, we're going to take the whole sustainability picture, as made up of balances between different things altogether. There's no, somebody else said, there's no silver bullet approach, and so on. And we'll stop there, we're all getting hungry, I think.
Well, thank you very much. I would like to bring this session to a close, and I thank all the speakers and panel members here with us. Let's give them a big round of applause. Thank you, gentlemen. You may return to your seats. Ladies and gentlemen, we'll be taking a short break for lunch. Lunch will be served to your tables. A quick reminder to all guests to make sure you keep your masks on at all times unless you're consuming food or your beverages. Please also ensure that you retain and stay within your respective seating zones and avoid mingling with other tables around you. Thank you and have a safe lunch.
Ladies and gentlemen, a quick announcement for you. Now, for those of you who've registered for the different tracks, we want to make sure that you have enough time to enjoy the lunches provided. So we'll only be starting the different tracks, the presentation for those tracks, at 1:30 p.m. So please be at ease and enjoy the lunch. Thank you.